Hello, do you hear me? Okay. So hello, my name is Paweł Kucharski, and I work at Google in display ad serving team in Dublin. For many years, I was doing startup in Warsaw. I was one technical founder for the startup. Then I moved to Google, and right now I'm in the team which is responsible for a big part of Google ad serving infrastructure. So how many? Is this working? Yeah. Sorry. So how many of you heard about the SRE? Right, cool. So if you haven't, that's a discipline. So my favorite definition to compare SRE to DevOps is that SRE implements DevOps. So this SRE is the way Google does production engineering. And Google does production engineering, defines the production engineering as a software problem. So I'm a software engineer, and my colleagues are software engineers, and we try to solve the production operation problems as software problems. So we don't like operations, we don't like toil, we like to automate stuff, and that's what we mostly do. So most of our time we spend on doing projects, finding a way to get rid of the operation work that we have to do. There is some part of work that will always be with us, like being on call and handling incidents, but we believe that the rest can be actually automated because machines are usually better with doing repetitive tasks than humans. So if you want to know more, we had books. We wrote 2 books, and probably there'll be more. You can buy them in bookstores, or you can find them on our website, google.com/SRE. They're available there for free. So this is a great reading if you want to know how Google does production and how Google thinks about production, then this is a great source of information for you. And today, we will focus on one chapter of the book, which is about how to answer those 4 questions. So how good is the service? How to know how good is the service, and how know how good the service should be. When we will answer those 2 questions, then we can actually think about when do we need to make it better, and how do we make it better. So this is the agenda for today, and let's start with the first part. So how good is the service? We use something. It's working. Sorry. Yeah. We use something which is called service level indicators. So there is a definition which is very Wikipedia one. But basically, we want a number. And probably you can have a lot of numbers which describes your service. And actually, describing complexity of the world with the number is a hard task. So that's why there are some requirements for the number. So we want, like, the number will be quantitative, but we want it to be measurable. So this has to be a number that we can easily measure, and we know how to measure. And this number will describe attribute of the service, like there are different, mostly commonly used attributes, like throughput, latency, so how long the work takes, or how much service can handle, or how often the service do work, or correctness, probably like you always care about correctness, because actually users don't like services that are super fast and super reliable, but provide bad content. You can have a lot of more like durability for storage system and so on. But from this whole world of numbers, we want to pick some which are more important than others. And what we care about is our users' perspective. So we want numbers that will allow us to understand user experience. What are the things our users care about? So when you have a web service, this probably can be latency. usually people prefer sites which are fast. There can be correctness, as we said, there can be availability. So this is not a question to SRE, this is a product question. So the product team should know how user interact with the service and be able to actually help to find those numbers. Once we have those numbers, we should make sure that we collect them. And this is very important to collect those numbers in advance. So if you don't collect them, that's the best time to start collecting them. You can collect by saving logs. So at Google, we have rich logs that have a lot of information, and we can extract a lot of things from the logs if something goes wrong, because we want to debug it. And you also probably want to have some real-time monitoring over these metrics to understand what's happening, because the log analyzing pipeline can be slow. When you have those numbers, then you can move to the next step. So choose which numbers are actually important, because you don't want to care about many different aspects of the service. And for sure, some aspects can be more important than others. So let's say that you have a service that does get and post requests. And probably, if the get requests are fast enough, then the post requests maybe are not that important for users once the page is loaded and users are using the app. So you should carefully choose the most important metrics and define service indicators. So the service indicators, here is an example. We choose latency as the most common one and the thing that users usually care about. But we don't care about every latency. We define that we want HTTP GET latency for properly formatted requests. You don't want to measure latency for some crappy requests sent by bots or something like that, which they are not your users, so you don't care about it. And you define how you measure it. Do you measure it by the black box? Do you measure it by the black box monitoring? Do you measure this on the server side, on the client side? Obviously, client side is better, because here we care about users, and the client side is the side. It gives you the better understanding of what is the actual user experience here. But somehow it's much harder to measure it on the client side, so you can measure it on the server side and assume that it's also fine. And you define where do you measure it. What is the universe of measurement? So here we have an example indicator where we define that we care about latency. HTTP GET latency, we measure this by the black box prober every 10 seconds across all the front-end servers. And this is pretty long definition, so probably you don't want to use this definition when you talk about SLI. So if you measure everything by the black box prober every 10 seconds, then you can just simplify this definition by saying client-side front-end GET latency and refer to that. But there is one important thing to understand when you define indicator. So you have to understand the metric. And the metric can not be what you think it is. So here we have an example system, which usually replies in 20 milliseconds. But sometimes people complain that the system is very slow. And this metric is measured every second, but it's aggregated in a 5-minute rolling window. So this is an average from 5 minutes. So we see just a little bumps, nothing really serious with the latency. But if we go deeper into bumps and we decrease our window, so increase the resolution, we will see that it's still fine. This is just a 1 millisecond difference. But when you move to 1 second resolution, so each point is a 1 second, you can clearly see some spikes in the monitoring, spikes of the latency. There can be multiple reasons for the spikes. Maybe clients are synchronized and do something every second. So there is, let's say, cron script, which starts every minute, at the same time, and this is probably a situation that you should avoid and spread the load across the whole time. Or maybe you have some reload in your job, and there is locking issue, which is causing latency increase for a short period of time. And this is just one example how the monitoring can lie to you. So if you don't fully understand the metric, then you can actually be tricked by the graphs. Another problem is that we don't like averages. Averages generally sucks because they lie to us about the world. It's really hard to describe the world with a number, but the average is the worst number you can have. So usually we care about distribution, about histograms, percentiles. So when we define our SLIs, we usually define them as a percentile. So here you have a graph for a service, and you have 50th percentile, 80th percentile, 90th percentile, and 95th percentile. And this is logarithmic scale, so this 90th percentile is 100 times more than the 50th percentile. And you see that the spikes are only visible here in the highest percentiles. So maybe we don't have to care about the median, and we can just focus on the highest percentile we care about, and that. If this is okay, then the rest will also be okay. And there is a paper, The Tail at Scale, wrote by Jeff Dean and Luis Barrasso. You can find in the web, which describes exactly this problem. So knowing that, we can actually better define our indicator. So now we care about 95th percentile of HTTP get latency, measured by a black box prober every second, aggregated every 10 seconds across all front-end servers. So we are avoiding those pitfalls. And once again, try to find a common parts. You can just, if you always measure this, your indicators like that, then you can just cite P95 client-side front-end get latency. Okay, so once we know how to measure our service properly, we can move to the question, how good should it be? And by how good, we mean how fast, how reliable, how available the service should be. And this is not a SRE question. So this is not an operation question. This is a production question. Because how good is the service comes with the cost. Every 9 in your availability comes with a cost which increase exponentially. And the product team should actually find a proper trade-offs between the cost for reliability and the cost and the income or the gain from the higher reliability. And if you think about the service which has a $1 million revenue, and you want to move it from 3 nines to 4 nines, so by just this move, imagine you will reduce your budget by 10 times, from 43 minutes to 4 minutes, and you will, and the cost you will, like the gain you will have will be like $900. So maybe there is no point for having 4x reliability service. So there is this expression, the sentence from Bay Traynor, who's saying that 100 target, which is sometimes people expect 100 reliability from the service, long reliability target for nearly everything. Maybe some critical systems are really worth having this kind of reliability, but the rest probably not. And your product team should make a call what kind of reliability you want to expect from the service. And this involves trade-offs with money, with people, time, with sacrifice priorities. Sorry. But for SREs, the main task here is to set the target to be achievable. Once, if you set it too ambitious and you won't be able to achieve, there's no point of defining those targets. So in our service, let's say that all the parties, so the product, the engineering team and the SRE team decided that the service should have 95% of latency below 250 milliseconds with 3 nines. And should respond to requests at least 99.9% of the time. So our service will be 3 nines, and this is the product goal, and the SRE teams that, yes, this is achievable with the current resources. And this we call SLO. And we decouple SLO from SLI. So SLA, it's a more like an agreement, so it's a lawyer term where the monies are involved. You don't have to have SLA. You can have SLO without SLA. You can just have this mathematical relation when you define that for my service, my SLAs should stay below targets or in some specific range. And this helps user to understand what they can expect from the service. So when I know what is the SLO for the service, I know how to expect how reliable the service will be. And once you know this, you know what are expectations for you. So you should probably do slightly better. You should have a buffer for some unexpected events, but you shouldn't overachieve. So we actually had problems with some service at Google that were too reliable. So they were strongly overachieving their reliability. And people start thinking that the services are up all the time and start using them as a critical dependencies. So whenever a service went down, all other services that were depending on the service were also down because they were not prepared for the service to be down. So what they came up with is that they decided to have planned outage. So whenever the reliability was too high, they were just randomly, in a controlled way, shutting down the service to show other users that, hey, this service doesn't have 100% reliability, and you should think about and design your service that it will be resilient to our failure. So once we have those two concepts, then we can introduce another one, which will help us to decide whenever we should focus on reliability. And these are error budgets. We use error budgets every day, and this is basically what help us to understand how healthy is the service. So the error budget is the remaining amount of errors that we decided that we will accept. So we said that we don't want to have 100% reliability. So now we have some budgets, and what do you with the budget? You try to spend it. You don't want to save it, you should spend it. And you can spend it in multiple different ways. So you can do releases, and usually releases involve some risk that things might get break. You can try to introduce new features. And new features also have some risks that they won't work. You can plan for failures, hardware, network failures. You can do some risky management work, which you can do the maintenance work much faster because you have some errors, so whenever things go wrong, it's fine because we have error budget. So usually our error budget, it's number of errors for some specific rolling window. It's a 40-day or a quarter. So we know how many errors do we have for a quarter. We can track this. And this helps us to balance between reliability and velocity. Because for SREs, the target is not to maximize the reliability. It's to maximize the developer's velocity, the product velocity, and just maintain the specific reliability level. So once we know our budget, we can then decide if we have a budget, then we do risky stuff. We release new features, we release new binaries, we do all this stuff which can cause errors. But once the budget is depleted, once we don't have the budget anymore, then we should actually switch our focus to reliability, to refill the budget and improve the service. And we can do it many different ways. But this also involves development, so the dev side is also involved in this. So this is not that the SREs shift their focus, it's that the development team shifts the focus. So right now the development team doesn't do releases, they work on improving reliability. Once you are more comfortable with working with error budgets, you can do more sophisticated things. So you can try control your piece of future releases based on the remaining budget. You can try to alert on the budget consumption whenever you see that there is some slow bleed that can actually cause your budget to be depleted. You can take some actions. You can create a special fund for some unexpected events, or you may have a silver bullet, so whenever you are in freeze, you still do some releases. So maybe there are legal requirements that you have to meet, and there is a deadline that cannot be moved. This can help you to actually release in this kind of situation. And the last part, how to make the service better. So SRE, the main task for SREs is to build a monitoring system. The SREs are responsible for knowing how good is the service, to measure SLIs, and to know if the SLOs meet or not. SREs can, as I said, help to set the targets in an achievable way. So they know what are the resources, they know how the service is designed, and they'll help you to set the target in a way that it's achievable, or set that if we want to achieve these targets, then we need more resources, that we need to redesign the service, or we need to do some, add some additional mitigation means to be able to actually provide this reliability. And also, we work every day with our dev teams on improving the service. So we are not focusing only on the production and operations. We also focusing on the service. So we work with devs to standardize infrastructure, to have means to mitigate the problems. We help to design the service. So whenever there is a new service and there is a big redesign, SRE can actually help to design the service in a more resilient way and avoid some pitfalls. We help to, and we configure the build, release, and rollback system. This is a very important stuff. So whenever, we know that the change to the system may cause trouble, so we want to roll back much faster and be able to roll back actually binary whenever there are problems. You can have phase rollouts. There was a talk about the service mesh, which can help with that. So you don't want to roll out binary globally. You want to have a phase rollout when you test things, and you have a load balancing, so whenever something goes wrong, the load balancing can help you to minimize the damage to the budget. But to achieve this, SRE must have the authority to halt launches whenever the error budget is depleted. And this requires strong support from the management and executives. So this has to be understood by dev management, by probably by the company management. So if we really treat a SLO as a thing to help us guide between the reliability and velocity, then whenever we are out of budget, we just stop doing new features and we focus on reliability. The SRE must also have the ability to return pager to devs. So if dev team is not committed to improving the service once the budget was depleted, there is no work for SREs there. SREs doesn't do operation work. So if the devs are not helping to fix the service, then SRE can actually give the pager back to them. And this is a common case at Google. So every dev team is also on call and is also responsible for some part of the service. So whenever the service is noisy, they also feel the pain, and they know that they can actually get the pager back if they won't fix the service. So this is a very important thing. And to be able to cooperate with devs, SREs has to have similar skills. So they must have ability to code, which is crucial. Okay, so 3 things to remember here. One thing that we use SLIs to understand how good is the service, what are the key metrics. Then we use SLO to actually know how good we want the service to be. And we use error budgets to balance between velocity and reliability, and to know when we should focus on one another. Okay? Thank you.